Hi, I'm Ganesh, and this is my hackathon submission. AI agents fail silently. A prompt might 4x a token's bill, a judge step times out, and a dashboard has the data but nobody reads it for you. So Cerberus is what I built, which is an AI SRE copilot that does the same. It reads your agent's telemetry back out of SigNoz, explains what actually broke, and writes the alert that would have caught it. Observe, explain, and prevent. So let me just run the casting file. Yeah, let's see if Docker's up and running. Yep, looks like Docker's up and running as well. So the entire project has its backend built on Python and Fast API, and it has a Next.js dashboard and telemetry, OpenTelemetry into SigNoz. The whole SigNoz stack plus its MCP server deploys from one committed Foundry casting file, which is basically Foundry CTL cast, and hence it is fully reproducible on a local device. Let me just create two failures because my agent emits OpenTelemetry traces, which will be the token, cost, latency per step, and so on. Let's just do them first. One error, let's repeat it again, and here we go. Second error. SigNoz derives a service metric straight from those traces. Here is the agent run operation with its error rate and latency. So let's now look at the traces. So this is one of the traces ID, but let's look at the home page. This is from the last 15 minutes so that it's fresh. Yeah, so this is the data that Cerberus reads. A failing run we have as the second one. The judge step errored and it carries the GenAI attributes. Let's click and see. Yeah, so this has an agent run which basically had around, I think, 4,000 tokens which have been spiked, and Cerberus was exactly these fields. If you scroll down, you can see all the fields through the SigNoz MCP server's query builder. So now let's go to the logs. Now if you go to the logs, you can see the frequency chart as well. But yeah, so these are the recent logs. Let's open at one of the error logs. We can see the input tokens being 4,000. And this is basically correlated with the trace that we just saw, and if you scroll down you can look at exactly the other details as well. Now let's go to the dashboard. I basically fetched all of this data and put it out into a visual perspective on the dashboard. So now the same telemetry is read back and ranked from worst to the first. So if you scroll down you can see the token usage and the recent incidents that have taken place. So let's do something cool now. So we can see the number of runs, the number of failed runs, the number of tokens used, and the estimated cost, right? So let's ask something to the copilot. What went wrong in the last few runs and what did it actually cost? Let us ask the copilot and let it give us a reply. So we can see that the same telemetry actually read back and it is ranked from the worst to the first. 2 runs failed at the judge step, and now we can see we added 2 more to the 12 runs that I had actually run earlier, and it is about 10x the tokens and the cost of the healthy runs. So I asked the copilot and it answers in plain English, grounded only in these facts, what is actually required, and citing the exact trace IDs as well. We can see over here. No hallucination, nothing. It's so clean. Right. So let us spike an alert over here, and we should be able to see it in the alerts tab inside SigNoz. Right. Let it fire it. Yep. Looks like it's done. And looking at the alerts, we can actually see that we do have 2 alerts. This is another alert that I created earlier. So once you click on the alert, we can see all of the alert rules that were set by us. So this basically closes the loop. One click writes the alert rule that would have caught this back to the same MCP server it reads from. Here they are. It's live in SigNoz, labeled generated by Cerberus, right? Observe, explain, prevent. So this is the entire loop that's covered inside SigNoz. It reads through the SigNoz's MCP server, writes to the same MCP server. That's Cerberus for you. Thank you so much.